Alright, you guys, this is the starting three problems. Just take a minute, actually take a couple minutes with your neighbor and see if you can figure out the slope for each of these three lines. Alright, we just need to choose 2 points on each line, and then we'll figure out the rise and run of each of these, and that will be the slope. But we got to simplify that, which we will use the calculators for anyways. So, number one, I'm going to choose this point right here, and what the heck, this one right here will do. So I can see from the triangle that I draw, or the stair step, that I'm going down, and then also to the right. But how far down am I going? Well, there's 1, 2, 3, 4, 5, 6, and then to the right, 1, 2, 3. Alright, let's try that one again. Rise over run. Yeah, the rise was down 6, so it's a negative 6. The run is to the right 3, that's positive 3. And there we go, that simplifies to negative 2. Alright, on number 2, same idea. Again, it doesn't really matter which 2 points you choose, as long as you can figure out their ordered pairs. Or that we can follow the grid lines to make the triangles. So this one, I'm going to show this triangle, and that one shows going up 1, 2, 3, and then also to the right 1, 1. Okay, so the rise is 3 and the run is 1, and that would simplify to 3. Next up, number 3, we can use these 2 points. Now we can't always use the intercepts, but in this one we can. So this one looks like it goes down 3, and then also to the right 3. So the rise is down 3, and the run is to the right 3. This simplifies to be negative 1. All right, let's get started on that worksheet. Throughout this chapter, the components of a linear relationship have been investigated. A linear relationship is defined by the constant rate of change, which is why it's a straight line, that it possesses, and it can be represented in many ways. In this lesson, the focus will be more on the equation that represents a linear equation. For example, the equation given below represents a linear relationship, y equals 2x plus 5. So number 1, the graph. We'll graph this equation of this line by making a table of values that represent solutions to this equation. And yeah, sometimes it's called the t-chart or t-table. In any case, take 1 minute with your neighbor and make or finish the table and the graph. Graph this equation again. So hopefully you finish this with your partner on this one. So I'm just going to kind of focus in on the table first. Now the nice thing about the table is it's going to give us some ordered pairs from this, alright? So let's look at that equation. But the thing about the equation is we're going to be replacing the x values on this. So I can erase that x right there. And I'll be replacing it with negative 1. Alright, so x now is negative 1. And then I'm just going to evaluate this. So y equals 2 times negative 1, which is negative 2, plus 5 would be 3. Very good. Now that's negative 1, 3. The next point will be with x is 0. Yeah, so let's look. Right, you guys say x is 0. And yeah, 2 times 0 is 0, plus 5 is 5. So that's a y value of 5 when x is 0. Alright, the next one. Now x is 1. So 2 times 1 plus 5 is 7. Very good. So when x is 1, y is 7. The last one in the table is where x is 2. And 2 times 2 is 4, plus 5 is 9. So y is 9 when x is 2. So that goes into the table, and we have completed the table. But let's compare this with the graph now. So the table, we need to remember, or hopefully we remember, gives us these ordered pairs. Like this would be negative 1, 3, The next one would be 0, 5. The next one, 1, 7. And then finally 2, 9 as ordered pairs. And it kind of indicates that with the table, right? It's X and Y values. So let's go to the graph and graph all these points. So negative 1, 3, right there. And 0, 5. Maybe I should make these bigger. There we go. Something like that. And 1, 7. And finally 2, 9 right here. Now that should create a pretty good pattern for us on this, and that's all we really need in order to graph this. So the last thing we're going to want to do is connect the points. And there's our line. Alright, now that we have the table and the graph, take a minute with your neighbor and figure out what the slope of the line is and where you see the slope in the equation. So I'll find the slope of this line. There's a couple ways we can find the slope. We could use the graph if we wanted to, but I think it's going to be easier if we use the table on this one. So from the table, we just need to choose 2 points like we've done before, and then figure out what the rise and the run is. Just remember, the y values indicate the rise, and the x values indicate the run. There we go. And the slope will be rise over run. So what's the rise on this thing? That's from 3 to 5. That means you'd have to go up 2 to get to 5 from 3. So that's a rise of positive 2. And the run from negative 1 to 0, that would be to the right 1. So that's positive 2 over positive 1, which is 2. Where do you see the slope in the equation? Alright, in the equation, and hopefully we can see this, the slope, 2, is right here. Does anyone remember what we call the number that's being multiplied by a letter? It is the rate of change. It's very good. In more technical terminology, this would be considered the coefficient. Number 4, often the letter B is used to denote the Y-intercept. What is the Y-intercept of this line, and where do you see the Y-intercept in the equation? Just take a minute and see if you can answer these 2 questions with your neighbors. Alright, you guys, the Y-intercept, and we've talked about this before, but more in terms of it being a starting value. The starting value is where the line crosses specifically the Y-axis. So it would be, in this case, this point right here at 0, 5 on the graph, and it's shown in the table where x is 0, like these 2 points. This point rather, which is at 0, 5. Now one thing to remember on the y-intercept is the x value is always 0, no matter what, which is why it's crossing the y-axis. So we get the point 0, 5. And where do we see the y-intercept in the equation? It's the number that's being added. It doesn't have any x's. It's just what they call a constant. It's just the individual number that's being added, or in some cases subtracted to the x's. Right, number 6, there's the table. On these ones, for each of the equations given below, make a table of values to help your graph the line. Then identify the slope and y-intercept. Circle the slope in your equation and put a star next to the y-intercept. Take a couple minutes to do this one with your neighbor. We want the table and the graph. Now this idea is kind of new, so again, if you struggled with it, that's okay. But the nice thing on this table is it did not tell us what x values to use, which means that we get to choose what x values we want on this thing, okay? So I'm going to choose some values that hopefully will work for us. I'm going to start with -1, and then I'm going to choose 0, 1, and 2. Now I'm choosing these specifically because I know they're going to fit on the graph, so that when I put these on the graph, again, they will be on the graph. If we chose, for example, 3, then we get an x value of 3, then the y value would be 13, which doesn't fit on the graph. So I'm just going to start with -1 and move my way up to 2. Alright, so the equation, y equals 5x minus 2, but we're going to be replacing that x there. Alright, so x is -1, so 5x, but now it's 5 times -1, which would be -5 minus 2. So that would be -7 on that. -7. Next up, x is 0. So again, we're just evaluating the equation with x is 0. And when we do that, 5 times 0 is 0. Minus 2 is -2. So we got this point at 0, -2. Next up, x is 1. Alright, so x now is 1. So 5 times 1 is 5, minus 2 is 3. So 1, 3. And then the final one, where x is 2. So 5 times 2 is 10, minus 2 is 8. So this gives us the ordered pairs in the table, which we can then put on the graph. And again, these are ordered pairs. So the first ordered pair we have -1, -7, which appears to be right there. And then 0, -2. And also 1, 3. And finally 2, 8. Right there somewhere. Alright, and then we'll just connect these points with the line. Something like this will do. Alright, so we've completed the table and the graph. The next thing we want to know is the slope and the y-intercept of the line. And we already know the y-intercept, which was given in the table and is shown on the graph here at this point, 0, -2. So the y-intercept is 0, -2. The slope on this one we should already know because it's the coefficient of the x is 5. So the slope is 5 and the y-intercept is -2. So we've identified those and we circle the slope in the equation and put a star next to the y-intercept. Bam, that is all. And I'll reiterate this, just remember if you guys chose different values in the table, that's okay, but the graph should always look the same no matter what. Alright, number 7, same idea, fill in the table and the graph, and then circle the slope in the equation and put a star next to the y-intercept after you've identified them. Take 1 minute to do this one with your neighbor. Alright, hopefully that's enough time. If not, just keep working, finish, and then follow along with what we have here on the board, alright? So in this one, let's have you guys choose the x values.
Can we do 4?
Alright, so you guys chose these values, some of you guys chose these values. Again, you may have different values, and that's okay. We'll just put whatever we can fit on the graph for now, okay? So on this one, we'll do this a little differently because when you plug these into the equation, we just expect you to be using the calculator anyways, not to do these in your head. So for example, this first one, right, we would have y equals 3 times x, which is -1, and then add 1 to that, alright? Again, just put that in the calculator and see what you get. So that'd be -3 plus 1, which is -2. Then when x is 0, 3 times 0 plus 1 is 1. When x is 2, 3 times 2 is 6 plus 1 is 7. And then finally when x is 4, 3 times 4 is 12 plus 1 is 13. Now we can't fit 413 on the graph, but it's okay, we can still have it in the table. So let's take these points, these ordered pairs, and put them on the graph. I got -1, -2. I've got 0, 1, And I've also got 2, 7. There we go, 2, 7, and 4, 13 would be somewhere, I don't know, somewhere up here. But again, that's not so important for this graph because we have those 3 points. Other points you may have gotten would have been 1, 4, or maybe even -2, -5, -3, -8. And how do we know that? It's because it has a pattern with it, okay? But you may have had those different values on there. Next, let's connect the points together. Something like this will do. And then, yeah, we can put the arrow at the end of these. Alright, so there's the table and the graph. The slope on this one, once again, is the coefficient of x, which is 3. And the y-intercept was shown in the table here at 0, 1. And on the graph right here also at 0, 1. So the y-intercept is 0, 1. Which on the equation is shown as the +1. So we'll start that next to it. Here's the next one, same idea. We want the slope and y-intercept identified. So fill out the table and the graph, and then circle the slope and put a star next to the y-intercept in the equation. Take 1 minute to do that with your neighbor. Alright, you guys tell me what values you want for x on this one. And these don't necessarily need to be in order like that. But this will work just for now. So, in the equation, we're just replacing x with those values we chose. So 4 times -1 is -4. 4 times 0 is 0. 4 times 3 is 12. And 4 times 2 is 8. So now that we have these ordered pairs, we can put them on the graph. -1, -4, 0, 0, 3, 12, which would be, again, it's off the chart, but that's okay. And then 2, 8, up here. If you use 1, you would have 1, 4, or -2 would also be -8. So we have this linear relationship which is shown just with the dots. Let's go ahead and connect those with the line. And that'll do. Of course, we'll put the arrows at the ends. Alright. Well, once again, it wants us to identify the slope. And the slope on this one is the coefficient of x still, which is 4. And the y-intercept, it's not showing it, but it should be showing a +0 right there. But we can see it in the table and in the graph here as well. It's the origin in this case. So we can put a star next to it there. Number 9. Same idea. We want the table filled and the graph completed. And then identify the slope and y-intercept. And then in the equation we'll circle the slope and put a star next to the y-intercept. Take 1 minute to do that with your neighbor. And this one is unique because the format's different on this one, right? We've been writing all the equations as y equals rate of change times x plus the starting value, but now it's in a different format, okay? So we got to be careful on this one. When we choose the values of x and then find the corresponding values of y, we kind of want values that are going to work for us. For me, I'm going to choose 0, 1, 2, and 3 on this. And that's because whatever x is, I'm going to add something to it and then make 3. Okay. So for example, if x were 0, what plus 0 equals 3? 3.
Oh.
So if x is 0, then y is 3. Okay. Now what about if we go back here, let's say that x is 1. 1 plus what value is 3?
2.
2. So that would be a 2 right there.
Oh, I need that.
Yeah, so we're gonna repeat this process until we finish the table, and then when we finish that, we'll put it on the graph. Okay. So the next value I've got x is 2, 2 plus what is 3? 1. So y is 1. Next up, again we'll replace these values. Where we chose x is 3. 3 plus what is 3? 0. So we have this ordered pair 3, 0, and these other ordered pairs, which now we can put on the graph. Alright, so the first point we had was at 0, 3, right here. The next point was at 2, 1. The next point, I'm sorry, 1, 2. The next point is at 2, 1. And the final point was at 3, 0, right here. So we have those 4 points, which now we will connect with a line. And there's our line. The last thing we got to do on this one is figure out the slope, but it's not the coefficient of x in this one because it's in a different format. So to find the slope on this one, I'm going to look at the table and figure out the changes, remembering that y is the rise and x tells us the run values. So if I went from 3 to 2, that would be down 1 for the rise. So I have a negative 1 over the run, which is to the right 1. That's a positive 1. And negative 1 divided by 1 is negative 1. And it's not actually shown in this equation as negative 1. So we're going to not worry about that part. But the y-intercept we've already found, again, in the table and the graph, at 0, 3, which did appear right here in the equation. Sorry, I'm supposed to put a star next to it. There we go. Alright, and we've completed this problem. Here's number 10. Again, they're not giving us a table, so if you wanted to, you could make your own. But we're going to look at it a different way when we go over it as a class. As it turns out, we won't need a table, but try to do it 1 minute with your partner. Go. So on this one, like I said, we don't need a table, even though you could if you wanted to, alright? What we do need is the slope, which we already see in the equation as the coefficient of x. That's 1 over 2. And the y-intercept here would be at 0, negative 2. So what this does is it gives us a point to put on the graph, and then from there we're just going to use the slope. Now these are both positive values, the 1 and the 2. But we remember from slope that it's rise over run. So the rise is showing as plus 1, or positive 1, and the run is showing as a positive 2. Now since that's a plus 1 or positive 1, that means we would have to go up 1 and to the right 2 from all the points on the graph. So when I put this point on the graph, 0, negative 2, right there, let me see if I can fix it. I'm going to use the slope of up 1 to the right 2, and that tells me where the next point is. Right there. But I can continue this pattern, and essentially this creates that stair step like we've seen before, which will give me the other points on this. However, once I've completed it to the right, it would be good if we could complete this to the left so that we can show the whole line. But we're just going to complete the stair step going in both directions. Now, it may not look very good because of the way it's drawn, but it should work. Alright? So we have all these points now that we can put on the graph from the stair steps. And then again from there, we're just going to connect these points with the line. Alright, so there it is. There's the line. Just by using the point, the y-intercept, and then the slope. Alright, again we got to do the same thing on number 11, but without a table. Again, you could create a table on this one if you want, which is okay. But take a moment and see if you can graph this equation by identifying also the slope and y-intercept. 1 minute with your neighbor, go. On this one, once again, we'll identify the slope, which is showing as negative 4/3. I'm going to write this specifically with the negative on the 4, even though you could with the 3, alright? And then the y-intercept, which is shown as positive 1 in the equation, so it would be 0, 1. Now remember, the slope is rise over run. So this one is showing a rise of -4. That means I'm going to go down 4. And the 3 is positive, so that will be to the right 3. And that's just from the point that we have to start with, which is the y-intercept at 0, 1, right here. So I'm going to go down 4, and then to the right 3, and then down 4, and to the right 3. And that's all I can fit to the right of that point, but I can continue this pattern if I go to the left. But in that case, I'm going to go up 4, and to the left 3. So that'd be left 3, up 4, left 3, up 4. There we go. And that gives us the other points to put on the line as well. All these points. And we just need to connect them with the line. Alright, there's the line. Again, we're just showing this because we don't need a table, but you can create one if you want. If you did, you would just get all these points that we have on here already. Like this one at 3, -3, maybe. You should have already gotten 0, 1. Maybe you had -3, 5. Or what is 1, -6, 9. And this other one here at 6, -7. Examine the graphs and equations given above. Describe the general form of a linear equation. In other words, in general, how is a linear equation written and what are its different parts? Take 1 minute with your neighbor and determine the general form for an equation and what the different parts represent. Alright, we should get something like this, and if we relate it to what we've done already, we know that it was always y equals, it was the rate of change for us though. And then we multiply that by x, and then we would add the starting value. Now again, on this one, these ones are a little different, but from the problems that we did last time, those were all in the first quadrant, but the starting value was always going through the y-intercept anyways. So for example, on that one with the babysitting, we had Irving's line which went through the origin. Let's see if that's supposed to go through the origin. And then we had Hendrickson line which didn't go through the origin, okay? But the y-intercept was where those values started. The problem is now we're extending the axes, which means we're also extending these lines like this, okay? So we got to be aware of where that y-intercept is, but in a word problem it would be just the starting value, and the slope is the rate of change, which we have written on the board over there as well. Alright, write down the general form of a linear equation in the box below based off your class discussion. Slope-intercept form of a linear equation is where m represents the slope or rate of change, and b represents the y-intercept or initial or starting value. Then answer 14, what if the y-intercept is 0? How do you write the general form of that equation? Take 30 seconds with your neighbor to answer these two. Alright, this is what we should get on that one. We got y equals mx plus b. This is a very general form for a linear equation. It's called slope-intercept form because specifically it gives us the slope as m and the y-intercept as b or plus b. So that is slope-intercept form. And then the general form for the slope-intercept form stuff of when the y-intercept is 0 is shown here at the bottom. Y equals mx plus 0 or y equals mx. Either one of those will work. Alright, so again, that's our objective for today. I can make a table and graph from an equation. And also, it may be good to know what slope-intercept form is, which we've discussed several times just in different forms. Alright, we're going to end the day with a short quiz. So take a couple minutes, you guys. Take everything off your desk first. And then get a piece of scratch paper out with something to write with so that we can take the quiz. Alright, you guys should have that taken care of. Let's go ahead and start on the quiz then. Alright, here's the quiz.
Oh, that's so
Okay, don't forget to put your name at the top of the page. And then use the graph to answer the questions. Number 1, what earnings will produce $225 in savings? Number 2, how much is saved from earnings of $400? 3, what is the slope of the line in the graph? 4, for each increase of $200 in earnings, what is the increase in savings? And 5, write an equation for the line. When you guys finish this, turn it into the basket. So I'm going to give you guys several minutes to do this quiz. Make sure you write your name at the top again. But once you finish, turn it into the basket. And then actually after you turn it in, we're going to go over it so you guys can see what you may need to fix. So go ahead and get started. Alright, let's go over this thing. So we got to be careful with what we're comparing on this one because the x-axis is representing dollars saved and the y-axis is representing dollars earned. So as we look at these problems, the first question says what earnings will produce $225 in savings? So that's savings, that's dollars saved. This line here represents $225. So we're just going to follow this line up until we meet the line, which shows this point. And what is the dollars earned on that one? That shows $1,000 earned for $225 saved. Next up, on number 2, how much is saved from earnings of $400? Well, earnings now, we're on the y-axis, that's the dollars earned, and that's $400 right there in purple, so I just follow that over to the line right here to this point, and that x value will tell me how many dollars were saved. And that's right in between 50 and 100, which means it has to be $75, the number right in between the two. The next question asks for the slope. So for the slope on this thing, we're going to look for 2 points we can identify, such as this one and this one. Now, when we create the triangle on this one, even though it's going up 2 lines, each line is representing $50. So it's really going up $100 in cash earned. And then it goes to the right here, even though, again, it's one line, each line is representing $25. So this would be $25 right here in dollars saved. So it's $100 earned for $25 saved, and this will simplify to $4 earned for $1 saved. Now, since it asks for the slope, we're not going to worry about labeling that thing though. Number 4, for each increase of $200 in savings, what is the increase in savings? I think I said earned. Let me try that one again. For each increase of $200 in earnings, what is the increase in savings? So I can just start with 2 points that I have, like this one here. And then I'm going to show $200 of increase. So that's from $500 to $700. Well, how far does that take me over here to this line? That appears to be $50. So for every $200 of earnings, you would expect $50 in savings. And it's kind of a scaled version of the slope that we have over there also. Last thing we want is an equation for this thing. So dollars earned will be representing by something multiplied by dollars saved. And we already found the slope was 4. The last thing we need is the starting value, which is shown in the graph right here. And that's the Y-intercept also, which is a positive $100 earned. And that would be the equation. So just think about what you did on the quiz and see how it corresponds with the values that we found. We don't necessarily expect you to get all those right. Some people kind of messed up on the slope because they were counting lines and not the scale of the axes. So you got to be careful on those. Alright guys, you should have all those turned in. Please put the calculators away and pick up the floor around your desk, and then you'll have to wait for the sub to excuse you.